Have you ever wondered what it really takes to build a brand new piece of tech from the ground up? A powerful little computer that's designed to think? Well, that's exactly what we're going to dive into today. The entire 20-week journey of the AI Now microserver, from just an idea on a whiteboard to a serious production-ready powerhouse. All right, so let's start at the beginning. What was the big idea here? To really get what this whole project was about, you've got to understand the vision. This was never about just building another computer box. It was about creating a totally new kind of machine for a new era of intelligence. And really, it all boils down to this one question. What if all the smart devices around us, our cameras, cars, you name it, didn't need to phone home to some server in the cloud to make a decision? What if they could process everything and react in an instant, right then and there?
Well, that idea has a name, and it's called Edge AI. It's all about putting the brain, the AI itself, directly onto the device. So think about a security camera that doesn't just record, but actually sees a threat and sounds an alarm on its own, instantly. No lag, no internet connection needed. That's the power of Edge AI. It's faster, it's more private, and it's a whole lot more reliable.
And with that, the mission was crystal clear. The goal was to build this, a super compact, really powerful little server that could be the local brain for all sorts of demanding AI tasks, something that could control other smart devices around it, and, this is key, be ready to go right out of the box. So how in the world do you go from a cool idea to an actual working machine in just 10 weeks? Well, welcome to phase 1. This was an all-out sprint to build the first draft, to turn a plan on paper into a piece of hardware that you can actually turn on. And let me tell you, this timeline was absolutely insane. We're talking major milestones getting knocked out every couple of weeks. In just 10 short weeks, they went from locking down the hardware choices to literally building the server's nervous system, installing its brain, and running the very first tests. It was just a flat-out sprint from start to finish. Okay, so to pull this off, they needed a few key pieces of the puzzle. First, you need the muscle, a powerful graphics card, a GPU, to do all the heavy lifting for the AI. Then, you need a tiny little chip that acts as the server's life support system. You throw in a super lightweight, stripped-down operating system for pure speed, you package up all the AI software in these flexible little containers, and then you top it all off with a simple dashboard to see what's going on.
Now, that little life support chip, the BMC, this is where things get really clever. The best way to think of it is as the server's subconscious nervous system. It's a tiny, completely separate computer that's always on, just monitoring the machine's health, the temperature, the power, the fans, making sure everything is okay even if the main operating system completely crashes. It's brilliant.
And just like that, after 10 weeks of heads down, intense work, they did it. They had a real functional prototype. A machine that turned on, ran AI models, and was ready for its very first demo. A huge, huge milestone. But, just getting it to run, that was only the beginning. Which brings us to the next 10 weeks, phase 2. And this is where the focus shifts big time. See, it's no longer good enough for the machine to just work. Now, it was time to make it win. It was time to go pro. And this quote, this basically became the mantra for the entire second half of the project. It runs is fantastic for a prototype, for a proof of concept, but it wins, that's the standard for a real product you can count on. So what does that shift from runs to wins actually look like in practice? Well, in phase 1, it was all about getting basic functions to work on one device. But in phase 2, the ambition just exploded. The new goals were lightning-fast, real-time performance, the ability to manage a whole fleet of these things, and automating everything so it was truly ready for the real world.
So to get there, the team basically launched an attack on 4 key fronts. First, they squeezed every last drop of performance out of the hardware. Second, they built what is essentially a mission control for managing tons of servers at once. Third, they created a whole ecosystem of tools for other developers to use. And finally, they beefed up the AI engine itself.
So what does a server that actually wins look like? What came out of all that hard work in phase 2? Let's take a look at the key features that turned this thing into a real powerhouse. First up is the Fleet Manager. This is the mission control center. I mean, just imagine, you've got dozens, maybe even hundreds of these servers running in a factory or spread out across a city.
This dashboard gives you one single screen where you can see the health, the status, the performance of every single one, all in real time. It's essential.
And for the developers who are actually going to build stuff with this, they made the whole process incredibly simple. It's just 3 easy steps. You find a pre-built AI model you want in their marketplace, you deploy it to a server with a single line of code, and then you monitor how it's doing.
So elegant, so efficient.
And here it is, the proof that all that hard work on performance actually paid off. This isn't just talk. When they put it head-to-head against some big-name competitors, the AI Now server just blew them away in key AI tasks. The proof is right there in the numbers. And let's put a hard number on that. All that engineering in Phase 2 led to a 20 to 30% performance boost over similar systems, especially when you push them hard over a long time. In the real world, that is a massive advantage. That's the difference between a system that just works and a system that truly wins. So, at the end of these 20 weeks of intense engineering, what we're left with is way more than just a fast computer. We're looking at a complete platform that could fundamentally change how we build intelligent devices from here on out. Because in the end, they didn't just build a box. They built an entire ecosystem. You've got the hardware that's ready to be deployed in fleets, you've got a custom operating system, and you've got a marketplace full of AI tools, all designed to work together perfectly. That is the real difference between a prototype and a true platform. And that brings us to the final and maybe the most important question of all. The hard engineering is done. The platform is built. We now have devices that can genuinely think for themselves, right out there at the edge of the network. So the only real question left is, what amazing, world-changing problems are we going to ask them to solve next?